concept of separation factor. The separation factor is denoted by letter beta. Okay, so as solvent extraction is used as a method of separation, so it is necessary to define the term which describes the effectiveness of the separation of the two solutes. Okay, the separation factor beta is related to the individual distribution ratio. As we know that we use a solvent for the separation of solute. Okay, so we are extracting solute from aqueous phase to the organic phase, right? So to define or to describe the effectiveness of separation of two solute, okay, in aqueous phase there was two solutes, so to separate that two solute from each other, we are using a solvent. Okay, so for the effectiveness of solvent, we are going to use one term. Okay, so how that solvent effectively separate two solutes from each other, okay, into two solvents. Okay, so that is defined by separation factor. So what is the separation factor? It is the ratio of distribution ratio. It is a ratio of distribution ratio. See, this is distribution ratio of solute A. This is distribution ratio of solute B. So see, so concentration of solute A in organic phase, okay, upon concentration of solute B in organic phase, divided by concentration of solute A in water upon concentration of solute B in water, that is equal to A0 upon AW, that is concentration of solute A in organic phase upon concentration of solute A in aqueous phase, that is DA, distribution ratio of solute A, divided by concentration of solute B in organic phase upon concentration of solute B in aqueous phase, that is denoted by distribution ratio dB. Okay, so the concentration of solute B in organic phase upon concentration of solute B in water or aqueous phase. So this is what the separation factor. Now separation factor is a ratio of two distribution ratio, that is distribution ratio of solute 1 and distribution ratio of solute 2, that is solute A and solute B. In cases where one of the distribution ratio is very small and other is relatively large, complete separation can be easily and rapidly achieved. But if the separation factor is large, okay, separation factor is large, but smaller the distribution ratio, okay, it is also appreciable, then extraction of both component occurs. What happens? We need to separate only one component. But what happens if the distribution ratios are very small? In that case, what happens if we are targeting solute A or component A, that comes in organic phase, but along with that component B is also coming because its distribution ratio is small. Okay, its distribution ratio is small. So in that case, we need to do some modification over there. So what we do in such cases, it is required to adopt the method to suppress the extraction of undesired component किंवा component B we can say. ज्या कंपोनेंटची आपल्याला गरज नाहीये त्याचं सेपरेशन जे आहे किंवा त्याचं सोल्युबिलिटी त्याच्यात सप्रेस करायची, कशात? ऑर्गॅनिक फेज मध्ये सप्रेस करायची, म्हणजे तो कोणाकडे राहील? तो aqueous phase मध्येच राहील. Okay, this is what the separation factor. So it is a ratio of distribution ratio of solute A and distribution ratio of solute B. Sorry. Now see types of extraction. Types of extraction. So what are the types of extraction? So this should be BY, this should be BY, not BY. extraction by chelation or by close ring formation, then extraction by solvation method, extraction by ion pair formation, extraction by synergistic extraction or synergistic method or synergic method, you can say. Four types of extraction. One is by chelation or ring formation, second by solvation, third by ion pair formation, and fourth by synergistic or synergic extraction. So out of which we are focusing first chelation. What is chelation? Okay, what happens here? Metal ion reacts with the ligand ion. Okay, so metal ion carries positive charge, ligand ion carries negative charge, so they react with each other. They forms a complex that is called metal chelate. That is called metal chelate. Now, how it is separated? See, metal forms two types of complexes. In one type, complex may be of open structure with the ligands. Okay, that is complexing agent bound to the metal. Complexing agent bound to the metal. In the second type, what happens? Metal get bonded through both covalent bond and coordinate bond. What happens? Ligand get bonded to the metal ion by covalent bond and coordinate bond. So the metal ion loses its charge and forms a chargeless species with the metal forming part of the closed ring structure. So metal काय झालाय? Now that is a part of closed ring structure, and that total structure is a chargeless. Okay, and the chargeless complex or the chelate can be easily extracted by using covalent nonpolar organic solvent. Covalent nonpolar organic solvent. Okay, so chelating ligand is having very important role in the extraction or separation of metal ion. The distribution ratio can be defined for the metal chelate as well as for the chelating agent. So the distribution ratio is defined as the ratio of metal chelate concentration in organic phase to the metal ion concentration in aqueous phase. Right? Metal chelate concentration in organic phase to the metal ion concentration in aqueous phase. That is called as a distribution ratio. Distribution ratio for the chelate. See, now they are there. Here is a chelate formation. Now we'll see what happens. See, the chelate are classified according to types of complexing group present in them. So if the complexing group is uncharged, म्हणजे जो ligand आहे तो uncharged असेल, so that results in the positively charged metal chelate formation. जर charge नाहीये ligand वरती, तो काय करतो? पॉझिटिव्हली चार्ज मेटल चिलेट तयार करतो. ओके, जर कॉम्प्लेक्सिंग एजंट इज हॅव्हिंग अनायनिक ग्रुप, वन अनायनिक ग्रुप, then that forms a neutral chelate. And if the complexing group or ligand is having more anion or more negative charges, then they form a negatively charged chelate. म्हणजे जर कॉम्प्लेक्सिंग एजंट कडे चार्ज नसेल तर कॉम्प्लेक्स तयार होताना पॉझिटिव्ह चार्जचा कॉम्प्लेक्स तयार होतो. कॉम्प्लेक्सिव्ह एजंट कडे फक्त एकच निगेटिव्ह चार्ज असेल तर तो एक पॉझिटिव्ह मेटलचा आयन आणि याचा निगेटिव्ह कोणाचा? कॉम्प्लेक्सिंग आयनचा. They forms neutral, and if the complexing agent having more negative charges, then they forms a negative chelate complex or negative chelate. Okay. मला खोकला येतो वारंवार. याचं कारण असं की संध्याकाळची वेळ आहे, स्वयंपाक झालाय घरामध्ये आणि तो मीच बनवलेला आहे. तेव्हा तुम्हाला असं वाटू देऊ नका की सरांना खोकला येतो वारंवार, काय प्रकार आहे. हा, सो तो मिरचीमुळे तुम्हाला खोकला येतोय आता. See here. So do you get it? Why there is a positive charge metal chelate formation, neutral metal chelate formation, and negative metal chelate formation. Okay, so depending upon the number of donor atom present in the ligand, they may be called as bidentate. म्हणजे त्याच्याकडे किती डोनर आयटम आहेत? 2 आहेत. Tridentate means 3 donor are there. Hexadentate means 6 donors are there. Okay, so calcium EDTA complex is a hexa-coordinate complex. Calcium EDTA complex is hexa-coordinate complex. Remember here, if the metal, sorry, the larger is the complex that is hydrophobic in nature, not hydrophilic. Hydrophobic means water repellent. It hates the water, so it try to get away from the water, get separate from the water. So where it will go, as you are adding organic solvent for the separation, definitely that complex, hydrophobic complex or large sized metal chelate complex will goes to the organic phase, okay, that can be easily separated. So this is what the example of larger metal chelate complex. This is a complex of copper with 8 hydroxyquinoline structure. This is a 8 hydroxyquinoline. 8 hydroxyquinoline. Such a 2 quinolines are getting attached to one copper atom. Okay, one copper metal ion. So that can bond to the copper, aluminium, and other, many other metals. Now we'll see one more is there, dithiazine. Diathiazone मी पर्पजली सेपरेट केलं. डायथायाझिन बघा, डाय मीन्स टू, डाय, डायाथायझोन. ONE stands for ketone, thiaz stands for sulfur. ओके बघा, एक सल्फर आहे. ओके, किती अजा आहेत बघा, 2 आहेत. ओके, dithiazone. Now another very important chelating agent used in solvent extraction is dithiazone. See, here is a spelling different one, here is a spelling different one. That is mistake from the book. Dithiazone and its a metal chelate are insoluble in water but soluble in chloroform and CCl4. That is carbon tetrachloride, CHCl3 and CCl4. Dithiazone can extract many metals like manganese 2, Fe3, CO3, nickel 2, copper 2, and zinc 2, palladium 2, Ag1, cadmium 2, lead 2. See, such a different number of complexes, metal ions can be separated by using only one ligand. That is dithiazone. Okay, sorry. The metal ion present in the aqueous phase. What steps are involved in the extraction are as follows. कुठले आहे? The metal ion कुठे असतो? That is present in aqueous phase. The chelating ligand or agent EHR is added with the help of organic phase. So it distributes itself between 2 phases. Which one? This chelating agent. In aqueous phase, it is dissociates as weak acid, that is H plus and R minus. पाण्यामध्ये गेल्यानंतर असा डिसोसिएट होतो. The metal ion Mn plus will get reacted with NR minus. Then that forms MRN. That is our complex. Okay, so the chelate MRN then distribute into organic phase. जो कॉम्प्लेक्स तयार होणार आहे कोणाचा, मेटलचा आणि लिगँडचा, तो कशात येणार आहे, ऑर्गॅनिक फेज मध्ये, आणि तो काय असतो, MRN. ओके, जो चिलेट तयार झालाय, जो कॉम्प्लेक्स तयार झालाय तो MRN आहे. आता तो ऑर्गॅनिक फेज कडे जाईल. जसं मी सांगितलं पेट्रोल मध्ये जाईल. समजा पेट्रोल आणि पाणी असेल तर पाण्यातून पेट्रोल मध्ये जातो. आणि अगोदरचा तो मेटल आहे ना, तो कशात होता, तो पाण्यामध्ये होता. आणि लिगँड कशाबरोबर टाकलाय तुम्ही, पेट्रोल बरोबर टाकलाय मध्ये. आणि ते शेक केलंय. आता काय झालंय, तो कॉम्प्लेक्स तयार झालाय, तो कोणाकडे आलाय, पेट्रोल मध्ये आलाय, असं समजा. This is just for understanding. Now see what happens. The various equilibria involved over there are, first, distribution of EHR between 2 phases. That is aqueous phase and organic phase. Then dissociation of EHR in aqueous phase. कसा डिसोसिएट झाला, H plus आणि R minus म्हणून डिसोसिएट झाला. formation of metal chelate, that is a stability constant for the formation of metal chelate complex. This is metal chelate complex form now. Okay, now distribution of chelate between two phases, दोन phases मध्ये तो डिस्ट्रीब्यूट झाला ऑर्गॅनिक आणि aqueous. बघा DMR हा मेटल चिलेट कॉम्प्लेक्स आहे, त्याचा डिस्ट्रीब्यूशन रेशो काय आहे, MRN concentration of chelate or complex in organic phase, concentration of complex in aqueous phase. Similarly, DHR concentration of EHR in organic phase and concentration of EHR in aqueous phase. What is EHR? It's a ligand you are adding with the help of organic phase to the aqueous phase. त्याच्यामध्ये टाकलेला आहे, जो तिथे जाऊन डिसोसिएट होतो. कसा डिसोसिएट होईल तो, EHR कसा डिसोसिएट होईल, as a H plus आणि R minus as a R minus. ओके, त्याचे दोन आयन्स तयार होतील. KF, okay, what is KF? MRN, concentration of MRN upon Mn plus Rn minus. आता हे कुठे दिसतंय आपल्याला, कुठे आहे हा, see here it is, Mn plus reacts with what, R minus. See, Mn plus react with R minus to form MRN. Mn plus react with R minus to form MRN. This is what our metal chelate complex. Okay, metal ligand complex, that is called chelate. Okay, now what is Ka? That is dissociation of acid. Okay, applying law of mass action to this reaction. Okay, and applying law of mass action to this reaction. Okay, so Ka is equal to concentration of H plus ion into concentration of R minus ion upon concentration of EHR. Okay, upon concentration of EHR. हा dissociate झालाय ना. Sorry, product of concentration of product upon product of concentration of reactant. हा तुम्हाला law of mass action माहिती आहे. Okay, so this is what we are applying to the two cases now, KF and Ka. So it can be shown as D is equal to distribution ratio is equal to K into concentration of EHR in organic phase and concentration of H plus ion in aqueous phase. Concentration of H plus ion in aqueous phase. Now, where D is a distribution ratio for metal chelate. D is a distribution ratio for metal chelate. K is a constant incorporating Ka of EHR and Kf of MRN. Kf of MRN. So Kd of EHR and Kd of MRN. Now see, don't get much confused over here. Okay, so up to this, that is enough. Okay, now D, the distribution ratio of metal chelate is independent of metal ion concentration. Distribution ratio D is independent of metal ion concentration. Okay, chelate of different metal get extracted at different pH values, and therefore by suitable adjustment of pH selectivity you can extract different metals from the solution. Okay, so it is important to adjust the pH to separate a particular metal ion from the organic aqueous phase to the organic phase. Okay, now I am repeating this slide again, whole slide I am repeating because it seems to be somehow more, you know. Next concept is a extraction by solvation. Extraction by solvation. See, now I am changing color. Wait. See here. What happens at various equilibria? Distribution of EHR between two phases. Okay. Then काय होतं की हा EHR हा aqueous फेज आणि ऑर्गॅनिक फेज मध्ये त्या ठिकाणी डिस्ट्रीब्यूट होतो. देन dissociate, it get dissociate in the aqueous phase as H plus and R minus. Then formation of metal chelate as what form? The Mn plus R minus forms MRN. Okay, MRN, here it is. Then distribution of a chelate between two phases. आता chelate दोन phases मध्ये गेला. कोणामध्ये काही प्रमाण त्याचं काही कॉन्सन्ट्रेशन ऍक्वियस फेज मध्ये आहे, काही ऑर्गॅनिक फेज मध्ये आहे. ओके, मग तो कसा दिलेला आहे डिस्ट्रीब्युशन रेशो. सो कॉन्सन्ट्रेशन ऑफ चिलेट इन ऑर्गॅनिक फेज अपॉन कॉन्सन्ट्रेशन ऑफ चिलेट इन ऍक्वियस फेज, दोन फेजेस मध्ये बघितले. दॅट इज कॉल्ड द डिस्ट्रीब्युशन रेशो ऑफ चिलेट. ओके, नाउ डिस्ट्रीब्युशन रेशो ऑफ HR is concentration of HR in organic phase upon concentration of HR in aqueous phase. Now by applying law of mass action to the reaction which forms metal chelate, so concentration of, so product of concentration of product, so this is the ratio of, okay, the ratio of concentration of this species upon the concentration of these two species is equal to KF. You can see that. Okay, हा n रेस टू होईल इथे. ओके, इथे रेस टू ला जातो तो. Now again for this reaction, which one? See, product of this reaction, HR gives you, see here it is written, HR gives you H plus and H plus plus R minus. So product of concentration of product, so this is product of concentration of product upon, see this is है ना, या टर्म आहेत दोघी इथे, या इथे आहे. ओके, अपॉन प्रोडक्ट ऑफ कॉन्सन्ट्रेशन ऑफ रिएक्टंट, इथे एकच आहे रिएक्टंट, त्याच्यामुळे तिथे प्रोडक्ट काय दोन येणार नाही, फक्त तोच एकटा येईल. दॅट इज व्हॉट द KA. देयरफॉर D इज इक्वल टू, D इज शोन ॲज K into ratio of concentration of HR in organic phase upon concentration of H plus in aqueous phase. Concentration of H plus in aqueous phase. So this is what the distribution ratio of metal chelate. So the distribution ratio of metal chelate. Okay, so the K is a constant incorporating K of HR and KF of MRL. Then and KD of HR, and that KD is not mentioned over here. They have not shown KD anywhere. Okay, so MRL. So D is the distribution ratio of metal chelate and is independent of metal ion concentration. Remember this only. So this equation I will repeat after finishing the topic. Okay, here it seems to be they have made some kind of, you know, the mistake is from their side. Okay, it is not clearer over there, so that's why. Now the next concept is extraction by solvation. So extraction by solvation we'll see in the next lecture. Thank you.